Welcome to the interval of convergence. Try it in my calculus try it series. Interval of convergence is trying to figure out what values of x we could plug in that would make a series that converges. And this is always going to be ratio test. And basically, we're just going to solve for the x's that will make this work. I'll do an example, and then I'll let you pause and try a couple. So ratio test says we are going to take the next term, the n plus first term. So we start by just replacing every x with an n plus 1. Every n with an n plus 1. Now, ratio test says divide by this nth term right here. But, of course, dividing by a fraction, you multiply it by the reciprocal. So the original term you were given, or original nth term. And we are taking the limit of this, because that's what ratio test says. And because we need it to converge, it needs to be less than 1. Okay? So now I like to simplify. I say, well, just kind of pairing up the x plus 4s. I've got an x plus 4 left in the numerator. I've got an extra 3 in the denominator. Now, because this is the limit as n approaches infinity, I'm going to leave the n and n plus 1 for the limit to deal with. But the rest of it, I'm going to kind of factor out front of my limit. So I've got x plus 4 over 3 times the limit as n goes to infinity of n over n plus 1. Well, this limit right here, that limit is 1. So you've got x plus 4 over 3 times 1. Well, that's x plus 4 over 3. Between negative 1 and 1. Now, the reason we put this negative 1 here is we need to know that the series could be alternating. A lot of times you'll see textbooks kind of maybe put an absolute value in here. That's a nice thing to do, to say absolute value. I usually just include it here at the end that, our goal is to be less than 1. But if you think about like a geometric series, it could also be greater than negative 1. So you're never wrong just waiting and putting it right here. All right, I'm going to now solve for x. So multiply everything by 3. Subtract 4. Like that. Now, this would allow us to figure out the radius of convergence. Right in the middle of this interval is negative 4. That comes from here, the fact that negative 4 plus 4 is 0. Negative 4 is in the middle, and it takes 3 units in either direction to get to the edges. So our radius of convergence is 3 from the center out to the edges. But to do interval of convergence, we need to check the end points. So what that means is we're going to plug in negative 7, and we're going to plug in negative 1 to our original series. So plugging them in for x up here. So if I plug in negative 7, I get negative 7 plus 4, I get negative 3 to the n on top, and then I get 3 to the n and times n. Well, this right here, this piece right here, negative 3 to the n over 3 to the n, reduces to negative 1 to the n. Well, this is a conditionally convergent series, okay? Negative 1 to the n over n. So negative 7 gets an equal sign because this led to convergence. When we checked that series, it was an alternating series. We used that test. Now, if I plug in negative 1, so negative 1 plus 4 into the original, I get 3 to the n on top, 3 to the n and n on the bottom. Well, these just divide out. That's just 1. So this just becomes 1 over n. Well, that is a divergent p-series. So this is our interval of convergence. Negative 1 does not get an equal sign because that did not lead to convergence. All right, here are 2 to try. Please pause the video, try to find the interval of convergence, and then I'll show you my work. All right, I'll show you my work now to get the interval of convergence. Again, if these videos help you, please like and subscribe. I have an entire series of examples and problems like this where you get a chance to try them. Okay, let's set up our ratio test. Multiply by the reciprocal. Now remember, you are setting this up so that it works, that we must get convergence. So we say, well, I'm going to take this limit, and it's definitely going to be less than 1. I have an additional x plus 3 in the numerator. N factorial divided by n plus 1 factorial is just n plus 1. Now, the stuff that doesn't have an n, I pull out front. So I'm going to say, well, I've got an x plus 3, and then times the limit as n goes to infinity. Well, it's 1 over n plus 1. This limit is 0 because the higher powered thing's in the top. X plus 3 times 0 needs to be between negative 1 and 1. I'm just going to put a 0 out here like that. Here's what's weird about this one. This is all real numbers. The interval of convergence is infinite. And the reason is, if I say, what could x be that would cause convergence? You say, well, I'm multiplying by 0. 0 times anything is going to be between negative 1 and 1 because 0 times anything is 0. So it leads to this interval of convergence. I don't even need to check the endpoints because, well, there are no endpoints. Okay? This is often true when you have a factorial in the denominator, that it doesn't matter what x is because no matter what, the denominator will be more powerful and we'll get convergence. All right, let's do the other one. Set up my ratio test. I'm going to multiply by the reciprocal. If you're doing this for the AP exam, I should just mention the importance of stating that you're taking the limit, setting this up correctly. It's worth a lot of points. Even if you maybe make some mistakes along the way, it's important to get the setup right. You're going to get some credit for knowing how to set this up. This I'm going to pull out front. So I've got x plus 2 times the limit. I always leave the n stuff in there because we're taking the limit of n. That's our variable that we're interested in. So I leave the n stuff in. I pull the other stuff out. Well, that limit is 1 because it would be, if I expanded the bottom out, it'd be n squared over n squared. So at this point, remember to add in your negative 1. If you'd rather put the absolute value ahead of time, you can. Subtract 2. Now we got to check our endpoints. So if I plug in negative 3, let me just kind of do this. I plug in negative 3 to my original series, and I get negative 3 plus 2, so I get negative 1 to the n over n squared. Well, this is using my alternating series test. This is absolutely convergent. This converges absolutely. So I put an equal sign on negative 3. I also am going to plug in negative 1. Negative 1 plus 2 is 1, so 1 to the n, which of course 1 to the n is just 1. But 1 over n squared is a convergent p-series. So this also gets an equal sign. There is my interval of convergence. If this video helped you, please like and subscribe for more in my Calculus Try It series.